So, in our previous session in Eigrp, we learned a lot of important, unique features of Eigrp. Like, it's very fast in convergence because it maintains a backup path. It's a distance vector protocol. It's advanced distance vector protocol. And we have multiple modules to support different network layer protocol. It uses multicast address to send the hello packet, and unicast to send the updates to established neighbor. No broadcast is in use. Broadcast is bad, so no broadcast is used. About the summarization, we have two types of summarization. One is the global summarization, the other one is interface level summarization. Global summarization is called as auto summarization. Interface level summarization is called as manual summarization. We also saw there is an algorithm called diffusing update algorithm, which guarantees a loop-free classless routing. At last, we also saw Eigrp can load balance even across unequal cost path. Followed by, we started going deep into those things. This is one page which I did not completely cover, which we'll be covering. And then this page, and then this page. Right? So let's quickly start from here once again, but I'm not going to spend much time like a previous class because it's already covered. Whichever I didn't cover, I'll focus more in this class. And we also need to do a small demo, a lab with Eigrp. So Eigrp neighbors are discovered using hello packets. Hello packets are sent with TTL value of 2, and it is sent to a multicast address 224.0.0.10. These informations I did not share yesterday. I'm just adding to this because I do not want to repeat the same thing which we already saw. And Eigrp uses a reliable transport protocol because it works in layer 3. Only layer 4 we have TCP. In layer 3, we don't have that connection-oriented approach. But Eigrp has got its own reliable transport protocol to provide that connection-oriented approach. To receive acknowledgement, to send acknowledgement. So Eigrp uses IP88. That's the protocol number reserved for Eigrp. Eigrp works in layer 3. That's why IP. Where does IP works? Layer 3, network layer. Eigrp works in layer 3. When Eigrp sends hello packet, they are sent to multicast address. The scope of multicast address is routed scope. Means only over the link. So 2 hop is what the TTL is, not more than that. Usually when a normal packet is sent from Cisco routers, the TTL used to be 255, time to leave. Means 255 hops the packet can go, the scope of the packet. But this is just 2 hops. And then dual algorithm is the reason behind loop-free classless best path. This one is like, we have separate module for IP, AppleTalk and all that. So We have three tables in Eigrp. One is neighbor table, which shows the neighbor list with which the neighbor is established. To understand the topology table, we need to understand this, which we are going to do in detail now. Eigrp selects the low cost path. How the low cost path is calculated? For that we need to understand what is advertised distance, what is feasible distance, what is successor, and what is feasible successor. These things we need to know before we understand how the low cost path is selected. Advertised distance is the metric to reach the destination. For whom? For our neighbor. Repeating again. Advertised distance of R1 to reach a network here. Let's say the network is 1.1.1.1. So we have R1, R2 and R3. The metric of R2 to reach 1.1.1.1, let's say it is 100. That is what becomes an advertised distance for R1 to reach the network 1.1.1.1. For R1, advertised distance for 111 is the metric of neighbor to reach 111. That is what they have written in different language. What is that? It's a cost between. It's a metric between the next hop router, which is neighbor. I use the word neighbor. Here they are using next hop. I use the word metric, they use the word cost. And the destination. So, metric from here to here is 100. That becomes the advertised distance for R1 router. Then what is feasible distance? The feasible distance is the metric between R1 to 1111. If you have multiple paths, the lowest metric, the low cost metric for R1 to reach the final destination, R1 to reach 1111. See, the metric between R1 and 1111, the destination is what? Feasible distance. The lowest metric. If you have multiple paths, the path whose metric is lower from R1 to R3's 1111 network. That's the feasible distance. Advertised distance is the distance or the metric advertised to R1. Who advertises to R1? The next hop advertises. So, feasible distance is nothing but the cost from the local router, which is equal to the advertised distance, this 100, plus the cost between the local router to the next router. Meaning, let's say here it is 50. So, what will be the feasible distance now? Advertised distance, which is 100, plus the metric between R1 and R2, which is 50. So feasible distance is going to be 150. Feasible distance is nothing but total distance. advertised distance is nothing but the total distance from my neighbor to the destination. Feasible distance is total distance from me to the destination. If I have multiple paths, R1, R2, R3, R4. Now for R1, there are two paths. Let's say the metric here is 10, here is 10, here is 10. The metric here is, let's say, 15, and here it is 11. We have multiple paths. For R1, there will be two advertised distance. One given by R2, the other one given by R4. The advertised distance given by R2 will be what? 10 plus 10, which is 20. Advertised distance given by R4 will be 25. 15 plus 10. So what is the total distance via R2? It is going to be this 10 plus the advertised distance, which is equal to 30. Via router 4, it's going to be 25 plus 11, 36. Now, what is feasible distance? Should I take 30 or 36? The lowest. They have not mentioned here. Okay, here they have mentioned low cost is the lowest feasible distance. So, 30 is the feasible distance. In another word, 30 is the metric of successor. So the one whose metric is lower is the successor route. So this is the elected path, the primary path, the successor route. Why it is successor route? Because that has got the feasible distance. What is feasible distance? The low cost path metric is feasible distance. So we understood what is advertised distance, what is feasible distance. Now we also know what is successor. Successor is the route whose total metric is low, whose metric is feasible. Successor is the route whose metric is a feasible distance. In another word, low cost path. Fine. What is feasible successor? Feasible successor is a backup route. Listen, if R2 need to be a feasible successor, please pay attention. This is something easy to understand. Feasible successor is nothing but a backup route. But all routes cannot become a backup route. For R4 to become a qualified backup route, it needs to satisfy feasibility condition. Feasibility condition. What is that feasibility condition? Says the advertised distance of the backup route should be less than this feasible distance of the successor route. So what is the advertised distance here? 15 plus 10 is 25, correct? Via backup path, what is the advertised distance? 25. Is 25 less than the feasible distance? What is the current feasible distance? 30. Yes, it is true. Only if this condition is true, this becomes a qualified backup path. It will not be seen in the routing table, but it will be seen in the topology table. If this condition is not met, for example, if I would have had 20 here, what is the advertised distance via R4? Can you please answer? What is the advertised distance via R4?
R4 should be 11.
Wait, let me write again. Here it is 20.
Okay.
What is the advertised distance via R4? Advertised distance is nothing but the metric advertised by R4. So what will R4 advertise?
Should be advertising 11. That's between R1 and R4, correct?
No. Advertised distance is the cost between the next hop router to the destination. So for R1, who is the next hop? R4. Yeah, tell me.
41.
30. 30, 20 plus 10 is 30. Exactly. So 30 is what router 4 is going to advertise. Now, what is feasible condition? Feasibility condition says that the advertised distance should be less than feasible distance. What is the advertised distance? 30. What is the feasible distance? The lowest metric is what? Feasible distance, 30. Is this true? No. 30 is not less than 30. 30 is equal to 30. So this route will not be considered as a backup route because the feasibility condition didn't met. Feasibility condition should met for becoming a qualified backup route.
So, Jay, question.
Yes.
So from R1 to R2 to R3, you're talking 30, correct?
Yes, 30, correct.
Okay, so then the feasible successor, the backup one, or it's supposed to be the backup one. R1 to R4 to R3, that's not 11 plus 20, 31 plus the 10 is 41? Am I reading that wrong?
That is right, 41. That is 41. That's right, 41. So R4 cannot be a successor because the metric is higher, right? This is just 30. This is 41. Lower the metric, better is the path. So we got the primary road. There is no problem. But for the backup path, R4 will be a backup path only if the feasibility condition is met. What does feasibility condition says? You see in the bracket here, the advertised distance of the feasible successor. What is feasible successor? Backup route. The advertised distance of the feasible successor must be less than the FD. What is FD? 30. What is the advertised distance of the feasible successor? That is also 30. See, the condition is the advertised distance must be less than the feasible distance. But here, is it less than? No, it's not less than. It is equal to. So even though there is a backup path, according to Eigrp, this won't be considered. This will not be considered as a backup path because it did not satisfy the feasibility condition.
Okay, and then if there is no, so then it will not have a, so just say we should just go on those two routes there. Because is that feasible successor not less than, it's equal in this term. In this case.
Yeah, equal is also not acceptable.
Two routes, so it's only going to have, just going to have one route.
Yeah, only one route.
That's what I'm understanding.
Yes, correct.
Okay.
Let me
If it has multiple routes, I'm sorry, go ahead.
let me repeat one more time with see 1, 2, 3, 4, 10, 101. Now this is 10 and this is 10 and this is 15 and this is 11 or something I wrote. Fine. Now for R1 there are two next hops. Who are they? Router 2 and router 4. So router 2 will be advertising 1.1.1.1 network with a metric of what? 20. And router 4 will be advertising 1.1.1.1 with a metric of 20? 25. Why 26? 15 plus 10 is 25, no? 25.
Oh, you're going from R2 to R3, and that's R4 to R3. Got it. I'm still looking to the left. Okay.
Now, what is the successor value, or what is the feasible distance? Feasible distance is nothing but advertised distance plus the distance between the metric between R1 and R2, which is 30. Via R2 it is 30. Via R4 it is 25 plus 11, which is 36. Now which one is lowest? 30 is lowest. So 30 becomes the feasible distance. So the path whose metric is 30 is the primary path. So this is going to be the primary path. Now will this be a secondary path? Will this be a backup path or not? For that the path needs to satisfy a feasibility condition. What does feasibility condition says? The advertised distance of this feasible successor. What is feasible successor? Backup route. The advertised distance. What is the advertised distance? 25. This 25 needs to be less than the current successor. What is the current successor? Via router 2, which is 30. Is the condition met? Yes, it is met. 25 is less than 30. So R4 is now, the path via R4 is now a qualified backup path. This backup path will be maintained in the topology table. When the primary path goes down, the backup path will be promoted as primary. So, feasibility condition is important for a path to be a backup path. Feasibility condition is important. Sorry. Next, I give you another example. What I said here maybe 25 or can be anything. Let's keep it as 25 this time. Now, is this a qualified backup path? Let us check. What will be the advertised distance from R4 to R1 to reach this 111 network? What will be the advertised distance? It will be 25 plus 10, which is 35. Now, is this advertised distance of the feasible successor? See, AD means what? Advertised distance of the feasible successor. What is feasible successor means? Backup path. Is this 35 less than the current successor value? This is the successor route. The current successor value is 30. Is 35 less than 30? No. It didn't satisfy the feasibility condition. Which one? This path. So this path will not be seen in the topology table. It won't be seen. Why? Because the feasibility condition is not met. Why is this feasibility condition? In case if there is a loop, the advertised distance will be greater than successor value. But unfortunately here, even though there is no loop, the advertised distance is greater, so it cannot use. Dual algorithm will not use if advertised distance of the backup path is greater than successor value. The reason is to avoid loop, that condition is kept. Now, did you understand this page?
Yes, I understand it.
Thank you. Now let's move on to the next page. So, as we discussed now, there is a topology table which will have successor route, feasible successor route for every destination, and then routing table. Routing table will have only the best route. Neighbor table will have only the neighbors, established neighbors, directly connected established neighbor. Topology table will have the topology, meaning all destination and their successor routes, and if feasibility condition met, the feasible successor also will be seen in the topology table. But in the routing table, we will have only those routes that are successors, means primary, the one with the lowest total distance. Here is an example. You see, router C has got two next stop routers, two neighbors, router A and router B. Router A is connected via E0. Router B is connected via E1. Now, advertised distance from router A for this network is 1000. And the advertised distance for the same network given by B is 1500. And the metric here and here is 1000. So the FD value will be 2000. This 1000 here plus this 1000 is 2000. See, in the topology table, for every destination, you will see the advertised distance and the feasible distance. Via B, if you see the advertised distance and the feasible distance, which one is lower? 2000. So 2000 route alone will be installed into the routing table. This will remain in the topology table for the backup. See, 1500, the advertised distance, is less than the successor value 2000. That is why it is here in the topology table. Otherwise, it won't be there in it. Is this clear? Thank you. Now, let us assume the advertised distance is 2000. This is 2000. Will this route be seen in the topology table as a backup route?
No.
No. Why? Because 2000 is the advertised distance and the successor value is also 2000. So it didn't satisfy the feasibility condition. So this will not be there in the topology table. Now a question. What if this route goes down? I don't have a backup route. What will happen? C will start querying the neighbor. The only available neighbor now is B. It'll ask B, do you have any idea about this network? Then B will say, yes, I do. And then it learns the route. And then only it will forward. So there will be some downtime. Because the backup path is not available, it has to discover the new backup path. Repeating again, when there is a backup path in the topology, the failure will not be seen. Immediately, as soon as the primary path goes down, the backup path will become primary. From the topology table, Eigrp will start using the backup path as a primary. But if I don't have a backup path, when the primary path goes down, when we don't have backup path, C will start querying all the router except A. It will start querying all other neighbors for destination 10.1.1.1, which is lost. And wait for the response. If anyone responds, then it will use. So it takes some time to send the query, wait for the reply, and then use the route. So there will be packet drop. So though we learned a top point called fast convergence, the fast convergence is only possible if you have a backup path. If no backup path, there will be query and response, which will take some time for the convergence to happen. Now, we learned this Eigrp has got hello packet is Eigrp packet type 3. I'll show you what is this 3. Update, query. Update is like sending update whenever there is a change. Query is, I just finished saying, if there is no backup path, asking neighbor about the routing information is what called as query. And the response for the query is what called as reply. For the update, there will be acknowledgement sent. When a query is received, acknowledgement will be sent. When a reply is received, acknowledgement will be sent to the one who responded. Now, this is how OSPF discovers neighbor. Sorry, not OSPF, Eigrp. Eigrp sends the hello packet. As I said earlier, it will send the hello packet with a TTL value of 2. And what will be the multicast address used by Eigrp? 224.0.0.10. Now, this hello packet, what will the hello packet carry? Please understand the question. What is that goes inside the hello packet? Number 1, I told you Eigrp uses autonomous system number. That number should match on both the router to form neighbor. This, if it is autonomous system 10, this also need to be autonomous system 10. Only then they will form neighbor. So that is sent actually. Autonomous system will be sent in the hello packet. Not only autonomous system number, even the K values. The K values also should match. What does K value means? The 5 metrics of Eigrp, actually 6 metric in the newer version. I'll show you. Here it is. This is what called as K1, K3, K2, K4, K5, and then hops K6, which is newly added. So these K values must match. Say for example, by default only K1 and K3 is 1. All the rest are 0, meaning they are not considered. Anything multiplied by 0 is 0. Reliability multiplied by 0 is 0, which means that Eigrp do not want to consider it. Now, if I have 2 routers trying to form neighbor, the K values of this one, the K values of this one also should match. So the K values are also sent in the hello packet. K values and the autonomous system number. We should not forget this. What does hello packet of Eigrp carries? Autonomous system number and the K value. I'll show you by capturing. I'll capture some packet using Wireshark and I'll show you in some time. Now, hello packet is sent from router A, and then router B also sends a hello packet. Before that, it learns the neighbor, and then it sends the update for which the acknowledgement is sent, and the update is now added to the topology table, processed, and now A is sending the update for which the acknowledgement is sent by the B. After some time, they both are converged. Means first they form neighbor by sending hello packet, for which the multicast address 224.0.0.10 is used. But the updates are sent using unicast address. Unicast address. Router B will use the IP address of router A, and router A will use the IP address of router B to send the packet. Unicast. Updates and acknowledgements are sent using unicast. Hello packets are sent using multicast. Is this page clear for you?
Yes.
Thank you. Now, this is another page. Bandwidth plus delay is the metric of Eigrp. Actually, these things are not that important, but still I want to explain you how Eigrp metric is calculated. Slowest link bandwidth. See, bandwidth is equal to 10 to the power of 7 divided by slowest link or minimum bandwidth of the link. See, slowest link bandwidth means what? In the path, the minimum bandwidth link is what called a slowest link. For example, in this path, this is the slowest link. This is 1500 kbps. T1 means in megabits it's 1.5 meg. In kilobits we write like 1500 kilobits. So in this direction via A, B, C, D, for A to reach D in this direction B, C direction, the slowest link bandwidth 64. 10 to the power of 7 divided by 64. Multiplied by 256. That's what you see here. 10 to the power of 7 bandwidth is 64 into 256. And how the delay is calculated? Delay is sum of delay 2000 plus 2000 plus 2000, which is 6000. So delay is in microsecond, you see. Delay is sum of delay in the path in tenths of microsecond multiplied by 256, which is like this. 1 to 6000 into 6000 multiplied by 256. This is what more than enough to know. Plus sum of delay, which is 6000 into 256. This is what going to be the metric of the path. This is how the metric is calculated. All the other things are formula. I told you K1 and K3 is considered. All the rest are zeros. They are multiplied by 0. It's of no use. So instead of knowing this formula, you need to know only this. This is enough. That's why they have put it in red color. We need not to say all these numbers. We can simply say metric is equal to slowest link bandwidth, which is this one, plus sum of delay, which is this one. See, multiply by 256, this is 10 to the power 7 divided by the slowest link bandwidth into 256. So this 256, 10 to the power of 7, not that important. We need to say at least this one. That's more than enough. Not at least, it's more than enough. Slowest link bandwidth plus sum of delay is the metric of Eigrp. Example here. If we are going via B, the slowest link bandwidth is this. Sum of delay is 2000 plus 2000 plus 2000 is 6000. If you go via XY, the slowest link is, all the links are same, so 256 plus 8000. So now you apply this to the algorithm and you will get an answer. Compare and then pick the one whose total distance is lower as the primary, the other one as a successor, feasible successor, if feasibility condition is met. This page is not really needed. Earlier we were having the class full protocol Eigrp. Class full is not good because everywhere we see subnetted networks. We need a classless protocol. That's why Eigrp was introduced. Eigrp is a class full. Eigrp is the second version of Eigrp. This is classless. But if you will have a very old router which do not have Eigrp, then what you can do is you can have the same autonomous system number. In here you run both Eigrp and Eigrp. So this will learn from here, this will learn from here, and the redistribution between these two will happen dynamically. That's what here it says. Eigrp metrics are backward compatible with Eigrp. You no need to redistribute. The metric is also compatible. Though Eigrp is only 24-bit metric, Eigrp is 32 metric, they are still compatible. The difference is 8-bit. So when you multiply Eigrp metric into 256, you will get Eigrp metric. In another word, if you will divide Eigrp metric by 256, you will get Eigrp metric. The reason is the bit. The bits involved in calculating metric in Eigrp is 32, whereas in Eigrp it is only 24. Any question in this page?
No, the question is on this one.
Right. So we have come to the end of this chapter. In this chapter we learned the features of Eigrp and the reliable transport protocol, which is involved in guaranteeing the delivery of updates. And then we got a protocol dependent module, meaning for IP there is a separate Eigrp module, for IPX there is a separate module. They all work on layer 3. We saw 3 different type of tables: neighbor table, topology table, routing table, and we learned about the advertised distance, feasible distance, successor, feasible successor, and we also saw how the metric is calculated. There are 5 K values. In the newer version 6 K values. Though we have 6 K values, only K1 and K3 is considered, which is bandwidth and delay. So metric of Eigrp is the slowest link bandwidth plus sum of delay. There is compatibility between Eigrp and Eigrp. This is not much important because we don't have Eigrp anymore. Now I'm going to do a small demo. Just 2 routers I have taken, R1 and R2. And for testing I would like to take a loopback interface on R1. Because after forming neighbor, R1 should send an update. So this network will be sent as an update. And in R2 I'm going to say 2.2.2.2/32. In between R1 and R2 I'm going to have 10.12.0.1/24 10.12.0.2/24. And one more thing is, okay, we'll keep that for the next class. Now I'm going to just configure Eigrp the usual way, the way which you might have seen in the past, but there is also another newer way which we'll see in the next class. Now let me use the classical way to configure Eigrp in these two routers. I'm on router 1, config T, interface loopback 0, IP address 1.1.1.1, interface F0/0, likewise on R2, interface F0/0, 10.12.0.2. Okay, we just got the IP address configured, that's all, just basic IP address. So if I ping from here 10.12.0.1, I will be pinging, pings, it pings. Now let me use a Wireshark so that I can show you some hello packet capturing between these two. Okay, so this is a Wireshark. Now I'm going to configure Eigrp on router 1. Router Eigrp, let's say the autonomous system number as 500. And then I'll say network 1000, meaning I'm saying any interface that has got 1 as a network should be part of Eigrp. Next, network 10. So on router 1, now Eigrp will be running on both F00 and 11111, means both interface. So F00 begins with 10, loopback begins with 1. Let's verify that. Show IP Eigrp interfaces. You see, it shows that these two interfaces are running Eigrp under the AS 500. Now I was telling you the hello packets will be sent. Look at this. Who is sending this hello packet? 10.12.01. Who is 10.12.01? It is router 1. Router 1 is sending hello. Will router 2 send hello? No, because we have not configured router 2. Now let me open this hello for you. See, hello is going from where? Router 1 to a multicast address 224.0.0.10, and you see the TTL value 2, and you see the protocol number 88, Eigrp protocol number 88. And I told you hello packets will carry the autonomous system number. Do you see that? Autonomous system number. And then it will carry the parameters like K values. You see this K values? K1, 1, K3, 1, all the rest are 0. So this is how the hello packets will look like. And I said the hello packet opcode is 5. It's not 3, it's 5. Now only one side we have configured, so there won't be any update. This will be keep on sending hello. Let's go and configure R2 now. Router Eigrp 500, network 2.0.0.0, network 10.0.0.0. Now you can expect update going. See, Eigrp updates. Let me stop the debug. Now I will open this update, the last update sent to router 1. Router 1 has sent update. Update is 1. Update is sent to a unicast address. No. Updates are also sent to a unicast address. This is common update. Let me go up. You see, updates are sent to a unicast address. 10.12.01 is sending to 10.12.02. It's an update. What does it sense? It sends, it's an init packet. Now let's go further. Open next update. This is carrying about the network. See, router 2 is advertising saying, I got a network called 2.2.2.2. It's /32. So they are sharing their routes that they know. As a result, if you go now to router 1, you should see the routing table with the route. Show IP route, you can see 11111. And then when I go to router 1 and check show IP route, I'll see 2222. It is all because show IP Eigrp neighbor, because router 2 is a neighbor. And show IP Eigrp topology, you can see the topology table. There is only one successor to reach 22222, that is VR router 2. You know what is this one? This one is an advertised distance. For router 2, the loopback interface metric is this one. And for router 1, the total distance is the advertised distance plus the metric between R1 and R2, which is this one. Yep. So, right now we see advertised distance and the feasible distance, the total distance. Yep. So the routing table will have only the successor route. I don't have an alternate path actually. I just got only one route. So only one successor. The routing table will have this show IP route, Eigrp has got the route. So 3 tables. Neighbor table, show IP Eigrp neighbor. Next is show IP Eigrp topology. Next is show IP Eigrp, show IP route Eigrp. 3 tables. Yep. Do you have any question? Right. I have demonstrated a simple basic lab in Eigrp. There are a lot of things to show even in this basic lab. I have a lot of things to show which we'll be doing in the next class. Kindly go through this video once so that you will be more comfortable in our next class. Thanks for joining today. See you tomorrow. Take care.
All right. Thank you.
Thank you.